Right. Hello to all of the Math8 students at Talbert. It's Mr. M here, and today we are doing a Math8 Unit 7 review. So, that Unit 7 review is something that you should have already done on Edulastic. Hopefully you've done it, you've seen your scores, you can even check what the right answer should have been. But today I want to kind of talk through this whole Unit 7 review as a way to basically review the whole Unit 7 on rational numbers, irrational numbers, roots, and all that kind of good stuff. So we're just going to go problem by problem, and we're going to start with question 1. Of course, if you don't need help with question number 1, feel free to fast forward this video and get to wherever you think you need help on. You don't have to sit and watch this whole thing unless you think that that would be beneficial to you. So this video is a resource for you to help you understand Unit 7. All right, question number 1, we are going to classify. That means we're going to take each of the following numbers and we're going to put it in one of these two classes. So this number is either rational or irrational, this number is either rational or irrational, and this number is either rational or irrational. How do you know which one is which? We have to know what a rational number is. A rational number is a number that can be written as a ratio. That's why it's called rational. Rational. Okay, so if you can write that number as a ratio, and by the way, that means a ratio of like something over something, like 5 over 3, some normal number over some normal number, something like that. Okay, so if it can be written as a ratio, it's rational. Is the square root of 1 rational or irrational? Well, what is the square root of 1? The square root of 1 is 1, because 1 times 1 is 1. So is 1 able to be written as a ratio? Yeah, it's 1 over 1, right? So that is a rational number. How about the square root of 400? Well, if you unsquare 400, guess what you get? You get 20, because 20 times 20 makes 400. Is 20 rational or irrational? It's rational, because you can just write that as 20 over 1. Then you get 12 times pi. Or, when you multiply that out, this crazy number with the dot, dot, dot. And what does that dot, dot, dot indicate? That dot, dot, dot indicates that this decimal will keep on going forever and ever without a pattern. And that means you will never be able to take that number and make it something over something. That is an irrational number. It's irrational. You can't make it a ratio. It's irrational. So how do you know how to recognize rational versus irrational numbers? Irrational numbers have a pi in it, right? Or they have a decimal that keeps on going forever and ever without a pattern. If this went on forever but it had a repeating pattern, it would still be rational. But it's that weird kind of unpatterned, going on and on and on forever-ishness that makes it irrational. That's the dead giveaway. So all right, let's do some more rational versus irrational on question number 2. Is the square root of 100 rational or irrational? Well, what is the square root of 100? 10. Is 10 rational? Yep. Because you can write it as 10 over 1. What about the square root of 10? All right, now, what times itself makes 10? I don't know. I can't think of any number. So that one would be one of these kind of decimals that goes on and on ugly style. That is irrational. Hopefully that makes sense. Now we're going to have to figure out a bigger number. Can we unsquare 225? And in fact, you can unsquare 225, and the answer is 15. So that is a rational number. I'm just checking to make sure that I did that right on my calculator here. Yep, 15 times 15 makes 225. So rational, irrational, rational. And hopefully that's making sense so far. We're going to go ahead and move on to question number 3. Convert. So we're doing conversions. We're going to go fraction to decimal. How do you convert from fraction to decimal? It's just a division problem. Top divided by bottom. So how do you do 11/30ths as a decimal? You're going to do 11 divided by 30. Woo! So how many times does 30 go into 11? It doesn't go into 11. 0 times. But if you put that decimal there, does 30 go into 110? Yeah, 3 times 30 is 90. Uh-oh. 20 left. So we're going to have to do this. Does 30 go into 200? Uh-oh. Yeah, I think that's 6 times 30 is 180. Uh-oh, we got 20 again. And we're going to have to do 6 times 30 is 180, and we got 20 again. So that 6 is going to repeat. So this is going to be 0.3 with a repeating 6. Don't put the line over the 3, because the 3 is not repeating. Just the 6 is repeating. Ah, tricky, tricky, tricky. You got to make sure that you get that right. And maybe on Edulastic, it's a little hard to know how to enter that number in correctly. So make sure that you're paying attention to the little details on how you enter these numbers in. Okay, 51/99. We can do the same process here. And if I go 99 into 51, it doesn't go, but I can add the 0. 99 is just about 100, so I'm guessing that 5 99s is going to make almost 100, almost 500, but it's going to be 5 short of that. So now I've got 15, and I've got to drop a 0. How many 99s go into 150? Just 1. 1 times 99. And I've got, let's see, what is that? 51. And then I dropped a 0, and look, I'm at the same place that I was before. So this is going to be 515151515151. So the answer to this one is 51, with both of them overlined, because it's going to go 51 51 51. And for the third one, you've got 4 3/8, and you might try to convert that into an improper fraction or something, but I know that this is 4 point something, isn't it? Because it's 4 wholes and then some kind of change left after that. So I just have to do 3 divided by 8 to figure out what the rest of that decimal is. And I'm going to have to do this same little trick. 8 into 30. Well, let's see. What time? 3 times 8 is 24. So I'm going to have a 6. I'm going to have a 60. Does 8 go into 60? Let's see. 8 goes into 60. Times tables. Oh my gosh, this is difficult. 7 times 8 is 54. Uh-oh. There's going to be... it's going to be 4.377777777777, I believe is the correct answer to that. I'm just going to verify that on my calculator. Oh, no, wait. No. It's not a bunch of 7s forever, because this is 56, not 54. Even Mr. Marbut can make math mistakes sometimes. So that's 40, and 8 goes into 40 5 times. It's 4.375. No lines, no repeated decimals, just 4.375. Whew, that was a close one. Sorry, I almost led you astray there. But if I can even make mistakes, that means you need to be careful to check your answers, because you can make mistakes too. So we're all human. We all make mistakes sometimes. That's why we need to check our work and double check our work. Okay, now we're going to go the other way. We're going to convert, but we're going to go from decimals into fractions. This is even easier. If you have 0.9, that's 9/10. Oh, I just converted that into a fraction. 9/10, right? 9 in the 10th spot. 61, and where does it end? In the 100th spot, so that's 61 hundredths. Now, one little note on these. Neither one of these were able to be simplified. Round, simplify, that's what I meant. Simplify. Reduce, right, if you can. Simplify or reduce them if you can. These can't be simplified, these can't be reduced, but if you can simplify them or reduce them, you should. All right, what are we going to do with the repeating decimal? It doesn't end in the tenths, it doesn't end in the hundredths, it doesn't end in the thousandths. So what do I put 713 over? It's going to be 713 over, oh yeah, the trick. Instead of tenths or hundredths or thousandths, we're going to use ninths or 99ths, or in this case, 990 ninths. That's the little trick, and once we know that little trick, then we should be good to go. All right, that is questions 1 through 4. Let's go ahead and take a look at question 5. Now we're going to find some roots. So, some of them are going to be easy, some of them are going to be more challenging. I think we all know that 64 is 8 times 8, so the square root of 64 is 8. We actually answered this one earlier. What times itself makes 225? 15 times 15 makes 225. So we're just unsquaring. Remember, that's not the same as dividing by 2. So is the square root of 64 32 because that's 64 divided by 2? No. We're unsquaring. We're not halving these numbers. We are unsquaring them. Okay, so what do we do with a fraction? With a fraction, all you have to do is square root the top and square root the bottom. And guess what? I know the square root of 4 is 2. I know the square root of 25 is 5. And that's it, 2/5, and you're good to go. Fractions aren't scary, no problemo. The only one on here that might be a little scary is that one. What does the little 3 right here mean? That little 3 means we're not unsquaring, we are uncubing. So we don't want to know necessarily that 64 is 8 times 8, because that would be unsquaring the 64. We're wanting to know what times itself makes 64. And in this case, you could actually have figured this out because 8 and 8 are each 3 2s. But that's still not a cube root. That would be like a 6th root. But each one of these 2s is a 4, isn't it? Each pair of 2s is a 4. So 4 times 4 times 4 makes 64. So the cube root of 64 is 4. And that's how you can go about kind of uncubing a number like that. Okay, now we're going to get a couple problems that are going to ask us to estimate an irrational root. When I say an irrational root, hopefully you can see what I mean. Is the square root of 20 going to be a nice, clean, rational number? No, because no nice, clean, rational number squared makes 20. So what is the square root of 20? I don't know. We could get a calculator and we could estimate that, and we would get something point something something something, and it would go on and on and on and on and on, right? But what if I just want to estimate it without using a calculator? That means I need to be able to do this in my head, right? Coming up with a good answer. So I want you to see that 1 is the square root of 1, and 2 is the square root of 4, and 3 is the square root of 9, and 4 is the square root of 16, and 5 is the square root of 25. So, of these 4 dots, which one would make sense to be the square root of 20? Is the square root of 20 between the square root of 4 and the square root of 9? Nope. So it's not A. Is the square root of 20 just a little bit bigger than the square root of 9? Nope. Can't be B. Is the square root of 20 between the square root of 9 and the square root of 16? No. 20 is between 16 and 25, and it's roughly right in the middle, close to the middle of those two numbers. So D is definitely the best choice for this problem. Now, what if I had actually not made this multiple choice, didn't give you a number line? What if I just said estimate the square root of 20 and said, tell me what you think it comes out to? Based on this graph, I would say, since the square root of 20 is about roughly the middle of the square root of 4, or the square root of 16 and the square root of 25, it's going to be 4 point something maybe 4.5, 4.6, something like that would be a good estimate. So you can find it on a number line, or you can kind of just guess based on what the nearest closest to actual squareable, unsquareable numbers are. All right, let's do that on number 7, the root of 31. The root of 31. You know what? As I'm reading this, these problems are not written perfectly. If it says estimate the root of the square root of 31, is it meaning like take the square root of 31 and then doing the root of square root of 31? I think it should just say estimate that. Estimate that. Maybe if you got these problems wrong on Edulastic because you thought that you were trying to do this, yeah, I could understand that's a little confusing. That's not worded very well. I'm going to go in and I'm going to see if I can edit the Edulastic test for next year so that that doesn't happen. Thanks for helping me realize that my test needs to get edited. All right, so we're not doing the root of 31. We're just going to do what is the square root of 31? Well, I don't know what the square root of 31 is. You don't know what the square root of 31 is. I do know what the square root of 36 is. So this is less than 6. Oh. Right, because this is less than that. What's the only number here that actually works? Point A is the only one that actually makes any sense on this problem because these ones are too big. This can't be the square root of 31 because if the square root of 36 is already here, this would have to be the square root of 37 or the square root of 38 or the square root of 50 or something like that. So it's got to be point A. That's the only one that would work here. Okay, now we're going to do one more of these. This one has a little twist to it, just a little twist. Don't worry too much. Which of the following best approximates the value of this? Now, this has a negative in the front. Okay, that's why we're on the negative side of 0 here. So, what is approximately the square root of 2? Well, this is the square root of 1. This is the square root of 4, right? Of course, they're negative. This would be somewhere in between there, wouldn't it? 2 is between 1 and 4. 2 is definitely not bigger than 4, like 9 or 16. So this would have to be point D, would be the best approximation for that value. Okie doke. Now we're going to compare some numbers. Compare and contrast. Question 9. The square root of 17, is it greater than 4.4? Is it less than 4.4? Or is it equal to 4.4? How are we going to figure this out? Well, think about the square root of 17. What's something that's close to 17 that is square rootable? How about 16? What's the square root of 16? 4. So what's the square root of 17? Is it going to jump all the way up to 4.4? Well, what's the next number after 4? 5. And that's the square root of what? 25, right? So is 17 about halfway between 4 and 5? Like 4.4 is about halfway between 4 and 4.5? No. This would be less than 4.4. This would probably be something like 4.1 or 4.2 or something like that, right? So this is less than that. Okay, 0.5, 0.5, and 5/9. When you do 5 divided by 9, you get a bunch of repeating 5s. So the real question here is what's greater, 0.5 or point repeating 5? Well, this is 0.50. This is 0.55. That's bigger. Hopefully that makes sense. All right. The square root of 36 is 6 because 6 times 6 is 36. The cube root of 216, what times itself makes 216? it's also 6. You can test that on your calculator. Yep, it works. So these two numbers are equal to each other. Alrighty. Then we've got question 10. We're going to solve this equation. Now, something squared equals 196. In other words, what number times itself makes 196? So, does negative 98 times negative 98 make 196? That's like almost 100 times 100. Is 100 times 100 going to be 196? Not even close. It's way bigger than that. Is that? No. Okay. So the mistake here is don't divide this in half. Unsquare this. And that gives you 14, right? Because 14 squared equals 196. 14 times 14 equals 196. So x does equal 14. The only problem with C is, what about E? Does negative 14 times negative 14 also make 196? Yes, because a negative times a negative is a positive, so x could equal negative 14. So what do I answer? Do I answer C or do I answer E? Oh, D to the rescue. This is saying x could equal positive or negative 14. Both of those answers would solve this equation. Did you know that it's possible for one equation to have two solutions? Yeah, it's possible. And this is an example of x could be 14 or negative 14. And so D is the best choice for that. All right, one more question. Number 11, the area. Oh boy, we got a square billboard. And it's a word problem. You know what we should do? We should draw a square billboard. Best square billboard ever. All right, and the area is 625. How do you find the area of a square? Don't you do this times this? Oh wait, what I'm basically saying is something squared equals 625. Yeah? So what's the measurement of one edge of the poster? That's x. If x squared equals 625, what do I have to do to that 625? I gotta unsquare it. And so we gotta figure out what number times itself makes 625. And in this case, that number is 25. So the answer is 25 centimeters. And you can double check that by putting a 25 here, putting a 25 here, doing 25 times 25, and seeing if that gives you an area of 625. And it does. So that's how we do that. All right. Thanks for watching. Thanks for listening. That's pretty much all I have to say today. Hopefully this was helpful, and you will be ready to take that Edulastic Unit 7 test tomorrow. Adios.